So I built this project in react.js and socket.io. So this was created using create react app. There is something called WebRTC, web web real time communication. This thing. So I think it is developed by Google. It is a technology uh, that we can use. It's free to use, which connects two or more hosts with each other without requiring a server. You only need the server to establish the connection. After that, those hosts can exchange data in a peer-to-peer manner. So the server which we use to establish the connection is called the signaling server, which we can write in JavaScript. So here we use a library called socket.io to, like, this thing acts as our signaling server. So it is based on events. So like on connection, we can define some events. The front end also has events, back end also has events. So the client initiates this process from the front end. He clicks on a button and an event gets sent to the back end, and that fires the whole sequence of events back and forth from back end to front end and front end to back end. So like on offer. So how it works is there is something called ICE, which is interactive connectivity establishment. So ICE is a process that uh, this signaling, there is something called as ICE candidates. So wait, so ICE is a process that happens with a stun server is, the full form is Session Traversal Utilities for NAT. So a stun server, like, is basically an ICE server. So it helps the machine such as this laptop to know who it is to the rest of the internet. So like, because this is connected to a Wi-Fi, and this laptop has a local MAC address and IP address on this local Wi-Fi network. But what is the address of this laptop for someone trying to reach it from the outside of our local Wi-Fi network? So to get to know that, we use a stun server. It gives us this address that we have for the internet. So these are offered by Google for to use for free. So this helps the laptop gather the ICE candidates, like this thing. So ICE candidate consists of one way to contact this laptop. So like there can be many candidates, many different ways to reach this laptop. So the ICE discovery process starts when this code gets called. So one by one, the candidates keep coming in. and this starts on both sides. So this project was made for two people only, two people trying to connect to each other for video conferencing. So so how it works is one of them starts the process, and when that person gathers his ICE candidates and sends a signal to the server, the other person knows that uh, the first person is trying to reach him. Then the other person starts his own process of ICE candidate discovery and everything. And then once we have the candidates for both of them through the signaling server, then we can connect them through WebRTC, and then the server is no longer required. If the server goes down, the connection will still remain between the two people. So yeah, so this requires an HTTPS because we are using the camera and microphone. Uh, so these, in order to use this, we require HTTPS, not just HTTP for our local host. So we can get that from a tool called, I think it was called MakeCert or something like that. We can get some keys here. You can look into it on your own. How to set up HTTPS on Windows on your local host. It is for free, and this is react.js, and I'm using ngrok to simulate an internet connection. Uh, so that, because otherwise it will be just local host, so that can seem like it's very easy. WebRTC is not working because it is meant to work over internet. So to simulate that, I'm using ngrok. It will expose our server to the internet. Anyone can access it with the URL, and then we can just access it and try to connect. So then there's something called offer and answer. So offer is an object you can think of. It is a special kind of object. So since there are two parties, one of them creates the offer and the other one answers it. So it is like sequential. So you can only answer when an offer is there. You cannot answer just like that. You, so first object that the server will receive should be an offer. After that, whatever object server receives, it will be an answer. So answer received, queuing complete. So like that means the same thing. So like once we have offer and answer, we sew them into each other. Like we send the person who sent us the offer, we send him the answer, and the person who sent us the answer, we send him the offer. So that's what this sewing means. Trying to create answer before offer is not permitted. This never executes actually, due to how we have set up the events to flow. And this is a signal, like you can send me the offer or the answer when I'm ready. And this is the server receiving an offer candidate or an answer candidate. Server just adds it into its list. And so we are using CORS also, cross all symbols. So in our env file we have defined this. So this will be exposed publicly through ngrok. So whatever value this is, it will allow a connection to this server from this URL. Then here we are using something. Use ref means to directly manipulate the DOM elements to keep a reference to them. Otherwise, when React refreshes the DOM to update the state, we will lose the reference to what they were. The reference will also be updated, so we don't want that. So we are using useRef. So then we are requesting permission for audio and video. Then we are setting up socket.io here. So we are defining all these events. And yeah, use effect. This will trigger it on the start. Will ask for the permissions whenever we load the page. So on open connection, this function is called when we click on the button. So it will go to these ICE servers and it will get the ICE candidates. This new RTC connection, this call itself sets up the server and starts gathering the candidates also. So yeah, whenever we get a candidate, we are going to emit on the socket. We are going to fire an event of the corresponding name. If I am the offerer, I will fire an offerer candidate event. If I am an answerer, I will fire this event with the value. And we are also going to add the tracks, the audio and video tracks that we receive on the connection. The other party's audio and video tracks. No, this is our local stream. So our own audio video tracks we are adding to the WebRTC connection. Yeah, so every connection has a local description and remote description. Our local description is who we are. So all our ICE candidates, our tracks, and everything. So once I offer and then I receive an answer, so I will set that answer as my remote description, and the offer was my local description. And so connection listens for a track event. So whenever we get a new track, this event is fired by the WebRTC technology. So whenever we have this track event, we are just going to add that track to our remote track. This means that the WebRTC has detected that the other party is trying to send us an audio track, a video track, or something else. So we are just going to add it to the remote track. Then disable. This is when we disconnect. We just set everything to null. So we have a video panel which has two videos. One is for me, one is for the other person, and a button panel. Open connection, close connection. It is very simple. And now I'll show you how it looks and works. Now to run this, we need something called ngrok. So so my ngrok application is on the desktop. Uh, yeah, there is this command that I wrote here. This starts two tunnels at the same time. So one tunnel exposes our server to the internet and the other tunnel exposes our client to the internet. So this URL I got for free by creating an account on ngrok. This one. This is our server on 5000. This is our client on 3000 localhost. This URL changes every time you launch ngrok. One of them is fixed, this one for the server. This one will change every time you run it. So we need to update this thing in the env file also every time we run it. Env file for the client. Here we are setting up HTTPS. So these two keywords need to be there for the SSL certificate and key file, and it will automatically npm will automatically pick this up when it is launching, and it will make our localhost as secure. Here are the files. So this is the server's URL which is fixed, and for the server we need to mention this because we have enabled CORS, cross origin resource sharing. So it needs to allow traffic from this URL onto itself. We will first start the server. So it is listening on 5000. Now we will start the client. So I turned off this volume because otherwise I will hear my voice twice. So open connection is being shown because it has connected to the server successfully. So now I will open this in incognito also. So now we have two windows. Both of them are connected to the server. Both are showing open connection. So I will open it from the incognito window first. And this one changes to answer connection. And I will answer it now. And now our streams are connected. And now I can close from this side or that side also, and this video will be frozen. I just close from here, it will vanish. And now without reloading it, I can open it again. This is to answer. So now it's, yeah. So here we have the logs. It receives the offer and receives the answer. Because we perform this process two times, it loads both of these lines two times. And now so this works through the internet. So it also works from my phone to laptop. So I turned on the mobile data, not the Wi-Fi, to show that being on the same Wi-Fi is not required for this. So I'll need to go to this URL on the phone. So it's showing to visit the site. It's asking for the permissions. And now it's the same web page. You can see open connection here. So I'll open the connection from the phone. This changes to answer. Answer. This is the feed from my phone, and I can see myself from the laptop also. And I will now close it from the phone. So without reloading, I will open this. This changes to answer. When I click on answer, we can reconnect. Yeah. Yes. So now we can just close everything. So this is how it works. WebRTC, it connects us through the internet. But in some cases, uh, when people are using a certain kind of NAT, which always gives you a new IP address. So in that cases, we need something called turn servers, uh, which stands for traversal using relays around NAT. So turn server is basically an intermediate. It will always need to be there to connect the peers. So, but in most of the cases, uh, yeah, we are not using a router like that. That will aggressively change the IP that we are assigned on the internet. So it also a stun server will be enough to just start the connection.